Hello, sir. So your mic is off.
Okay, significance of design of components. First component will take it as gear. You are observing here that in this gear cracks are developed on two sides. One is here, another is here. Why these cracks are developed? There may be different causes of this development of this crack. It may be the whatever material we have selected for the gear, it may be wrong, or there may be manufacturing defect, or there may be
Sir, screen is not visible.
huh hello.
Sir,
Screen
PPT
is
are
not
not
visible, sir.
visible.
Screen is not visible, sir.
One minute. hmm. There may be different causes of this gear failure. There may be improper material distribution, or improper material selection, or whatever thickness of the gear provided, it may be less as compared to the standard one. Therefore, these are the different causes of gear failure. Now next, this is the article which is published in, or which was published in Hindustan Times. That title of the article is Safety Gear Failed in Mirage Crash that Killed Both Pilots. Therefore, sometimes you are knowing that aeroplanes are there. These are fighter jets, Mirage, Tejas. These are the fighter aircrafts are there. Therefore, in these aircrafts, gearbox is present. Sometimes, if safety gear will fail, then we are knowing that whatever that aircraft is there, it is getting collapsed, and because of that, these pilots are also killed, and whatever that aeroplane is there, that is also crushed. Therefore, this is the nothing but importance of the design. Now you are observing this crashing of aircraft, that is fighting aircraft. Then next, gearbox failure caused fatal 2016 crash. Now this article is there because of gear failure. What is going to happen? This article was published in Denmark, Copenhagen. Because of this fatigue fracture of the main rotor of the gearbox caused an Airbus helicopter to crash off Western Norway in 2016, killing all 13 people on board. Norway's Accident Investigation Board said Thursday. Means because of this failure of the gearbox, whatever that helicopter was there, Airbus helicopter, it was crashed, and because of this, or whatever all 13 people are there on board, they lost their lives. Therefore, this is nothing but importance of design or significance of proper design. Now next, this pressure vessel failure. Now pressure vessel, what is meant by pressure vessel? You are knowing that whatever that gas tankers are there, we are observing on the road. Gas tanker, petrol tanker, diesel tanker, then milk tanker is there, water tanker is there. Also, while going to Solapur in Pakni, you are observing that various types of vessels are there. Hindustan Petroleum or Bharat Petroleum, that station is there where petrol and diesel is filled in the tanker. While traveling on the road, you are observing that very big vessels are there in the Pakni. Therefore, that vessels are nothing but pressure vessels. Why it is called pressure vessel? Because whatever that liquid or gas or fluid is there, fluid means liquid and gas. Whatever fluid is filled in the tanks, they are filled under pressure, or whatever that inside that tank some pressure is there, which may be less or which may be greater than the atmospheric pressure. Therefore, whatever that fluid is filled in the vessel under pressure, and that's why that vessel is called as pressure vessel. Now, boiler is also one type of pressure vessel. Therefore, you are observing in this figure that there is a failure of the pressure vessel. See that this pressure vessel is there, it is failed. Now there are different causes of this pressure vessel failure, same as that of here, that improper material selection. Also, in case of pressure vessel, mainly welding is used to connect different plates to each other, or different sheet metal is there to each other. Therefore, if failure of that welding takes place, definitely failure of the pressure vessel will take place. See that this is the enlarged view. This is the failure of the pressure vessel. Same case is here. This is the failure of the pressure vessel. Therefore, what is the importance of design? Why this design is important? Design, if we will design the properly, then that life of the component, it will get increased, and we have to take into account safety measures also. Now, before starting first chapter, again I will tell, there is one point in machine design which we have studied, that is nothing but factor of safety. Depending upon that factor of safety, that life of the component is either increased or decreased. Now, you may be knowing that you are sitting on the bench, and that bench plywood is having some thickness. Therefore, suppose 10 thickness plywood will use, and 3 students will sit on the bench. Therefore, that bench will carry the load of, the bench will carry the load of 3 students. If I will suppose decrease the plywood thickness to 5 what will happen? Suppose 3 students will sit, 3 students of 60 kg each, therefore 180 kg total load will be there on that plywood. Therefore, that plywood will fail. And if unnecessarily I will increase the thickness, required thickness is 10 and if I will increase the thickness up to 15 or 20 that means if thickness of the plywood is increased, therefore I have to increase the cost, purchase cost, purchase price will get increased. Therefore, here that factor of safety comes into picture. Your factor of safety should not be too low so that component will fail, as well as your factor of safety should not be too much high. If your factor of safety too much high, then you have to pay for it. Means you have to pay in terms of money. Means you have to spend more money if you will increase the factor of safety. Therefore, while designing the component, you have to take appropriate factor of safety. This may you have studied in machine design 1, but this factor of safety is important in the design subject. Now we will start our chapter number 1 or unit number 1, spur and helical gears. First of all, we will see spur gear. Now its content is design considerations of gears, gear materials, types of gear tooth failures, hunting tooth, gear tooth loads, minimum number of teeth, face width, Lewis equation, Spott's equation, Buckingham's equation, gear design for maximum power transmission, introduction to AGMA code, and helical gear, virtual number of teeth, force analysis, beam and wear strength, effective load on gear tooth. Therefore, this is the syllabus of first chapter. Now, directly, I will not start that design considerations of gears. First of all, we will see some preliminary theory of gears. That is what is meant by gear, what are its advantages, limitations, types of gears. Then we will see some gear terminology, because this it is not covered in any chapter or in any syllabus whatever you have studied. Therefore, first of all, I will take some introductory part. Then and then you will understand the future things. Therefore, first chapter, spur gear, or first point, spur gear. Now you are observing these diagrams. This is the spur gear, and this diagram is nothing but two spur gears are in mesh externally. Here external contact is there, and that's why these we can say that two gears are meshing externally. Now, how you are identifying the gears, or what is the definition of gear? Whatever figure you are observing, if anyone will see this figure, he will say that this is the gear. And if suppose mechanical engineer will be there, he will say that this is the spur gear. Therefore, how you are identifying the gear, or what is the definition of gear? Now, all are saying that gears are used to transmit power. Yes, it is correct. But this is not the definition of gear. Definition of gear is, if teeth are provided on the circumference of a disc to transmit motion and power, then it is known as gear. Means, how you are identifying the gear? If there will be a teeth, there will be teeth on the periphery of the disc, then it is known as gear. And this is spur gear. What is it by spur? Spur means projection. Spur means projection. If you will see, these teeth are projected outside, and that's why it is known as spur gear. And also, why it is also known as spur gear? Because teeth are parallel to the axis of the gear. Teeth are parallel to the axis of the gear, and that's why it is known as spur gear. Now, if you will see this diagram, these two spur gears are in mesh externally. Therefore, if you will see, this is the axis. This is the axis of the first gear. This is the axis of the second gear. If you will see, spur gears are used to transmit motion and power between the two shafts when the two shafts are parallel to each other. Therefore, this is nothing but spur gear. Now, introduction. Again, that definition of gear is there. Any toothed member designed to transmit motion to another one or receive motion from it by means of successively engaging tooth is called a gear or toothed gear. In generally, we are saying gear only. We are not saying tooth to the gear, because if gear is there, then there will be teeth on the periphery of the disc. Therefore, a gear is a toothed wheel with teeth cut on the periphery of a cylinder or a cone. Teeth of one gear meshes with teeth of the other gear. Hence, it is called a mesh drive or positive drive. Why it is called as positive drive? Because there is no friction or there is no power loss. Whatever exact velocity ratio, it is transferred from one shaft to another shaft, and that's why it is known as positive drive. Or there is no sleeping phenomenon. You are knowing, in case of belt drive, that creep and slip phenomenon is there. That does not exist in case of gear drive. That's why gear drive is known as positive drive, because of no loss of power or motion due to friction. It is preferred when medium or larger power is to be transmitted. Rotation of one gear will cause rotation of the other in the opposite direction. Now, what are the advantages of gears? Gears offer the following advantages. First, compact drive on account of small center distance. Second, high efficiency, reliable service, and simple operation. Third, positive drive due to negligible slip between contacting surfaces. Fourth, give higher speed ratio and can transmit higher power. Fifth, it is possible to transmit power between parallel, non-parallel, intersecting and non-intersecting shafts. And sixth, power can be transmitted at higher speeds. Now, limitations of gears. The limitations of gear drive are: first, the error in tooth meshing may cause undesirable vibrations and noise during operation. Second, costlier than belts and chain drive, because manufacturing of the gear requires special machines and tools which are costly. Third, power cannot be transmitted over long distances. Fourth, precise alignment of shafts is required. Fifth, require continuous lubrication. Applications of gears. The gear drive has wide applications in the following fields. First, metal cutting machine tools. That is, you may have seen gears in lathe machine, milling machine, shaping machine, in planing machine. Whatever machine tools are there, or in case of drilling machine also, you will find gears. Second, automobiles. Automobiles, you are knowing, our two-wheelers are there, four-wheelers are there. In case of four-wheeler, trucks are there, then aircraft, helicopter. Everywhere you will find gear drive is there. Then tractors. Then fourth, hosting and transporting machinery. That is material handling equipments. In case of material handling equipments, worm and worm drive is used because it is having high speed reduction. Then rolling mills, then marine engines. That is, in case of ship also, gears are used. That is, gear drive is used in case of ship also. Then next, classification of gears. Now, gears are classified according to how they are transmitting the power between the two shafts. Now, first is parallel shafts. In case of parallel shafts, gears are classified as spur gear, helical gear, double helical gear, and herringbone gear. Double helical gear is also known as herringbone gear. Then gears can be used to transmit motion and power between two intersecting shafts. In that, four gears are there, that is straight bevel gear, spiral bevel gear, zero bevel gear, and phase gears. These all four types are of bevel gears. Bevel gears are used to transmit motion and power between two intersecting shafts. Then non-parallel, non-intersecting. In that, spiral gears, hypoid gears, and worm gears. Therefore, this is nothing but overall classification of gears. Again, there are two types of classifications according to the position of teeth. That is, if teeth are parallel to the axis, it is known as spur gear. If the teeth are inclined with respect to axis, then it is known as helical gear. If the teeth are of spiral shape, it is also known as spiral gear. Then, according to the pitch line velocity, gears are also classified as low velocity gears. Low velocity gears means pitch line velocity is less than 5 meter per second. Then medium velocity gears, in which pitch line velocity is between 5 to 10 meter per second. And high velocity gears, in which pitch line velocity is greater than 10 meter per second. Therefore, gears are also classified according to this way. Now, first of all, we will see spur gear. Now you are seeing the two diagrams of the spur gear. First, two gears are meshing externally with each other, and in the next diagram, two spur gears are meshing internally with each other. Now, first of all, we will see these two spur gears. Now, if this bigger gear, always remember, bigger gear is known as wheel and smaller gear is known as pinion. Therefore, if this wheel will rotate clockwise, this pinion will rotate anti-clockwise because of external meshing. Always remember, when two gears are meshing externally with each other, then their direction of motion is opposite. Therefore, these two spur gears are meshing externally with each other. Therefore, their direction of motion is opposite. Now, this second figure. Now, in case of this second figure, this bigger gear you are observing. This bigger gear is known as ring gear, RING, or it is also known as annular gear, or it is also known as internal gear. Why it is known as internal gear? Because teeth are cut internally. These two gears are external gears because teeth are cut on the external periphery. That's why it is known as external gears. This ring gear or annular gear or internal gear, in which teeth are cut internally. That's why this is known as internal gear. And to this ring gear, this pinion is meshing. Therefore, this pinion is having external teeth, and that's why this is also known as external gear. Therefore, when two gears are meshing internally with each other, see that these two gears are meshing internally with each other. Therefore, in case of internal gearing, the direction of motion of both the gears is same. Always remember, because if this ring gear will rotate clockwise, this pinion will also rotate clockwise, and this is known as internal meshing. This is known as external meshing. Mesh means to contact. Mesh means to contact. Mesh, there are different synonyms of the word mesh. Mesh means contact, engage, or joined. Means three words are there. Synonyms. Synonyms means in Marathi it is known as Samanarthi Shabd. Therefore, spur gears are used to transmit motion and power when the two shafts are parallel to each other and their teeth are parallel to the axis of the gear. Therefore, this is known as spur gear. Now next, helical gear. Now you are observing helical gears. First of all, we will understand what is meant by helical gear. In case of helical gear, teeth are at an angle with respect to axis of the gear. Therefore, you will find it that here teeth are cut at an angle. Teeth are cut at an angle on the periphery of the gear. Therefore, these gears are known as helical gear. Now, in case of helical gear, there are two types of gears again, right hand helical gear and left hand helical gear. How you are identifying right hand helical gear and left hand helical gear? If in case of right hand helical gear, if you produce the teeth here or if you will extend these teeth here like this, if you will sketch the line, just I will tell. Now suppose this is the axis of the gear. If you will sketch the line like this along the teeth, and if that line of the teeth will intersect towards right side, see that towards right side, then it is known as right hand helical gear. If now suppose again this axis is there, suppose you will extend the teeth of the gear and it will intersect towards left side to the axis. See that this is intersection point. Then it is known as left hand helical gear. See that if you will extend the teeth here like this, it will intersect to the axis towards left side. That's why it is known as left hand helical gear. And always remember, in case of helical gear, right hand helical gear meshes with left hand helical gear. Right hand helical gear is in contact with left hand helical gear. Now next, double helical gears or herringbone gears. Double helical gears or herringbone gears. Therefore, why these double helical gears are used? Again, we will go to the single helical gear. These helical gears are known as single helical gear. Why double helical gears are used? Because if you will find that when the two helical gears they will come in contact with each other. First of all, contact will start at a point, that is point contact will be there. That is whatever force will be there, this gear will exert force on the teeth of this gear at the tip of the teeth. Therefore, if sudden impact will be there, then there are chances that the tip of the teeth will break. Therefore, this is the advantage of, sorry, this is the disadvantage of single helical gear. That is, while engaging or while two gears are coming in contact, the first of all point of contact is point and then it extends to the line contact. Therefore, whatever at the point contact will be there, therefore sudden force will act on that point and there are chances that tip of the tooth will break and there will be failure of the gear. Therefore, to avoid that failure of the tip of the tooth, double helical gears are used. In case of double helical gear, you are observing the teeth are like this, so that there will be smooth engagement of the two gears. There will not be any noise, or there will not be any breakage of the tooth or breakage of the teeth of the gear. And that's why this is known as double helical gears or herringbone gears. Now, before seeing this straight bevel gears, we'll see here double helical gear. Now, what is happening in case of double helical gear? When these two teeth are coming in contact, first of all, one force will act like this, and another force will act like this. Therefore, these two forces will get neutralized, and there will not be any sudden force or sudden jerk when the two gears are coming in contact. And that's why double helical gears are having smooth operation as compared to single helical gears. What is the difference between spur gear and helical gear? That I will tell when I will start the chapter helical gear. Now, this is known as bevel gears. Now, you see, bevel gears are used to transmit motion and power when the axes of the two shafts are intersecting. Now, you see here, uh, axis of this gear is vertical like this, axis of this gear is horizontal. Therefore, if you will imagine the axis, you will see that axis of the two gears are intersecting with each other. Now, when the two bevel gears are transmitting motion and power at an angle 90 degree, then they are known as mitre gears. They are known as mitre gears. Now, this is straight bevel gear. Why it is known as straight bevel gears? Because teeth are cut straight on the periphery of the gear. That's why it is known as straight bevel gear. Now, this is spiral bevel gear. Why it is known as spiral bevel gear? Shape of the teeth, it is of spiral shape on the periphery of the gear, and that's why this gear is known as spiral bevel gear. Now, zero bevel gears. Why it is known as zero bevel gears? See the diagram. Whatever that earlier we have seen, this spiral shape. Spiral means somewhat helical shape is there. Therefore, here angle is there. These teeth are making some angle with respect to axis of the gear, or it is of spiral shape. That's why this is known as spiral bevel gear. Now, this is zero bevel gear. I have shown here separately. Zero bevel gear. If you will see, teeth are not straight, but it is also, they are not spiral shape also. That's why they are known as zero bevel gear. What is the use of zero bevel gear? When I will teach bevel gear chapter, at that time again I will explain all the what is meant by straight bevel gear, spiral bevel gear, and zero bevel gears. Now, next type of gear is hypoid gear. It was developed by Gleason for driving rear axles of automobiles in 1925 in the US. It is mainly used for cars. A hypoid gear is used when the included angle is square and distance between axes are relatively small. The hypoid gear is viewed as an intermediate between bevel gear and a worm gear. Now, you are observing these two diagrams of hypoid gear. Now, just see the second diagram. In case of this hypoid gear, whatever that bigger gear, it is known as crown gear. This is the axis of the crown gear. Now this small pinion is there, it is in contact with this crown gear, and this is the axis of the small pinion. If you will observe, this is the offset distance, means distance between the center lines of these two gears. It is very small, and that's why these two gears are known as hypoid gear. Now next is worm and worm wheel. Next is worm and worm wheel. Therefore, if you will see the first of all this worm wheel, you will find that this is only a simply gear. Worm wheel is nothing but one simple gear which is having teeth are of spiral shape cut on the periphery of the gear. And this is the worm. Worm is nothing but threaded screw. Always remember, worm is nothing but threaded screw. Now you are observing that the diameter of this worm wheel, it is also known as pitch circle diameter. The diameter of the worm wheel is bigger as compared to diameter of the worm. That means, suppose if this worm gear will rotate by one rotation, this worm will rotate by maybe 50 revolutions or 100 revolutions. Therefore, whenever we have to transmit motion and power, or we require great speed reduction ratio, maybe from 1:50 to 1:100 at that time, or maybe 1:20, 1:30, 1:40, 1:50, up to 1:100. At that time, we have to use worm and worm wheel. At that time, we have to use worm and worm wheel. Worm and worm wheels are generally used in material handling equipments. Also, you will find worm and worm wheel. It is in case of our table fan. Whatever that box is there, in case of table fan, whatever that fans are there, and if you will open that box of that table fan, you will find that their worm and worm gear is used. Also, worm and worm gear, if you will see the axis of the worm is horizontal, and it's like this. I will draw here. Axis of the worm is like this. And if you will see the axis of the worm wheel, axis of the worm wheel is like this. Means worm and worm wheel are used to transmit motion and power when the two axes are perpendicular to each other. When the axis of the two gears are perpendicular to each other and they are not intersecting. Axes are not intersecting, but axes are perpendicular to each other. At that time, you can use worm and worm wheel. Now, next gear is rack and pinion. Rack and pinion. Now you just see this is the pinion. Pinion is nothing but it is of circular shape. Therefore, this is the pinion which is rotating, and this is the rack. Rack is known as straight gear. Always remember, rack is known as straight gear having infinite pitch circle diameter. Having infinite pitch circle diameter. Therefore, this rack and pinion is used when we have to convert rotary motion into linear motion or linear motion into rotary motion. At that time, we have to use rack and pinion. Now you see this terminology. This is the rack gear. Whatever this circle they have shown here, middle circle, this is known as pitch circle of the gear. This is known as pitch circle radius. This is known as circular pitch. Distance from one point of the gear tooth to the corresponding point of the next gear tooth, that is known as circular pitch. All these definitions we are going to see. And this is the rack gear. Rack gear is also known as straight gear, which is having infinite pitch circle diameter. Therefore, this is rack. This middle line is known as pitch line of the rack. Middle line is known as pitch line of the rack, and this is known as linear pitch because this is linear distance. Why this is known as circular pitch? Because if you will connect these 2 points, this point and this point, it will look like an arc. The arc is nothing but it is of circular shape, or it is one part of the circle. Arc is nothing but one part of the circle, and that's why this pitch is known as circular pitch. This distance is linear distance, that's why this pitch is known as linear pitch. Therefore, this is nothing but rack and pinion. Now, this table 1.1 indicates the most useful fields of application of the main classes of gears. Now you just see when we have to use which gear. When the two shafts are parallel and we want gear ratio up to 10, that is speed reduction ratio 1:10, and we want that tooth speed or that linear speed 5 meter per second, then we can use helical gear or straight gear. Straight gear is also known as spur gear. Again, up to 25 meter per second or up to 200 meter per second, we can use helical gear because spur and helical gears are used to transmit motion between two parallel shafts. If shafts are intersecting and we want gear ratio up to 7, then we can use spiral bevel gear or straight bevel gear. If the shaft axes are not intersecting and crossed at 90 degrees to each other, just now I have explained, and we want gear ratio up to 1:50, then we can use worm and worm wheel or crossed helical gear. Then if shaft axes are not non-intersecting, cross at 80 degree to 100 degree but not 90 degree, gear ratio we want up to 50, then we can use worm and worm wheel. Therefore, this table shows when we have to use which gear for which speed reduction ratio. Now, next point is terms used in gears. There are 25 definitions are there that I will take in next lecture. Therefore, now please write your roll number in the chat box. Write only one time only. Don't write twice so that there will not be any confusion. We will stop here. Thank you very much.